In these next couple examples, we're going to be working from practice 6-7, which is the worksheet that you received during class. We have a rhombus RHCP, okay, and we have a C is at 0, 0, the origin, and P is at -a, comma, -b. So if we're looking at x-axis, this would be -a, and your y-axis would have a -b right here. So we have -a, -b. So if we continue counting here, this would be -1a. So this would be -2a, and then -3a would be out here. And we can also do the same thing with the -b. If we go -b and 0, this would be +b. We could continue and put 2b up here if we wanted to and keep labeling. So our first letter, A, is looking for the coordinates of point R. Point R is over here. And again, this is a rhombus, so we know that it is symmetric on both sides. So in order to find R, we have to go 1a, 2a backwards. So this is going to be -2a, but we don't go up at all, so the y-coordinate will be 0. For H, we will go backwards 1a and up to b. So again, your y value comes from this mark here, and your x value from this mark here. So we have a -a, +b for our coordinate H. Okay, and we can label these on here as well. We'll put -2a, 0 for R, and -a, b for H. So letter C says to find the midpoint of RH. So we use all the information that we found, and we're going to find the midpoint of RH. So our midpoint formula, remember, is x1 plus x2 over 2 and y1 plus y2 over 2. Okay, so x1 plus x2 over 2 and y1 plus y2 over 2. Okay, now that we have that, we plug in our coordinates. R and H are the 2 points that we just used, so we add our x's together. -2a minus a over 2 for your x coordinate. For the y, b plus 0 over 2. And if we reduce that, -2 minus 2 is -3a over 2. And the y-coordinate would be b over 2, because b plus 0 is just b. So this would be our midpoint. This would be the answer to part C, the midpoint of R and H. For D, we have to find the slope of RH. And I'm going to erase just this midpoint portion here so that we can do our calculations. Okay, so make sure you've copied that down. If you need to, just go ahead and pause the video. Okay, so we're going to do slope for D. And remember, slope is y2 minus y1 over x2 minus x1. And remember, the order of the points doesn't matter as long as you put the first, whichever point you pick to go first, you use it first for both. So it doesn't matter if I do this minus this or this minus this, as long as I do them in the same order. You can't flip them in the middle. So we're going to subtract y's. I'm going to go ahead and put the b in front. So b minus 0 will be on the top. And again, that's y2 minus y1. And since I put b on the in front, -a has to be in the front on the second part. So -a minus -2a. Now, something to be very careful of is if you're subtracting, this negative sign, the subtraction sign is different than this negative sign. You need to make sure you're including both. And remember, a double negative becomes positive. So b minus a, or b minus 0, I'm sorry, over -a plus 2a. And if that's simplified, it will become b over a, because b minus 0 is b, and -a plus 2a will be positive 1a. So b over a would be the reduced version of your slope. So that is example number 2 from our first. So now we'll go ahead and look at example number 3 on the same page. Okay, example 3 has a kite. Okay, and it's ADFS. ADFS is a kite, and we have, I'm going to draw my picture just a little bit smaller this time so we have more room to do calculations. Okay, and I have a little smaller on the bottom and a little bit taller on the top. And A is at the top labeled 06A. Okay, D is 4A0. F is 0, -2A. And S is the one that we do not know. Okay, so the first thing we want to do for letter A is to find the coordinates of S. So just like many of the other ones we looked at, remember we do have symmetry here. So if we go over 4 spaces, 2, 3, 4 to get to this one, we also want to go 1, 2, 3, 4 spaces to get to the other side. So we're going to make S -4A, and 0 will be the y coordinate because again we are not going up at all. We are just going backwards -4 and not going up at all. Okay, so we'll label that on the graph as well. S is -4, 0. Okay, and then for B, we want to find the midpoint of AS. So B is midpoint of AS, and A is 0, 6A, and I'm just going to write that there so that we have A and S right next to each other. And the midpoint, remember, is x1 plus x2 over 2 and y1 plus y2 over 2. Okay. Then first thing we want to do is add our x's. So we will have 0 plus -4a over 2 and 0, or rather 6a we'll put in front to keep it consistent, plus 0 over 2. Okay, so when I put these together I have -4a over 2 and 6a over 2. And we can do a little bit of reducing here. Okay, we can divide this in half and get 2, -2a, and 3a. So that would be the midpoint of SA or AS. The slope of AS is part C, so we'll do that over here. So for part C we want to do slope. And remember slope is y2 minus y1 over x2 minus x1. Okay, when we plug in our numbers, again we're using this a and s here. We want to subtract the y's, so we'll do 6a minus 0. And since I started with 6, I have to start with 0 for the next one. And this will be 0 minus -4a. And again, please be careful of that negative. It needs to have that double negative. If you don't have the double negative, then you would not, you'd end up with a backward slope. It would have the wrong sign. So when we do this, we now get 6a over 4a, because remember this becomes 0 plus 4a. And you can do some reducing here. A over a is just 1, that cancels. And 6 over 4 reduces to 3/2. Okay, so that's part C. The slope is 3/2 and the midpoint is -2a, 3a. And like the last time, if you need any more time to copy down, go ahead and pause the video. I'm going to just erase those couple questions so that we have space to work on D and E. So D and E are finding the midpoint and slope of DF. So for D, we're going to be using the point D, which is 4a0, and F, which is 0, -2a. Okay, so now the first thing I want to do is write down my formula again. So x1 plus x2 over 2, y1 plus y2 over 2. We plug in our x's, x1 plus x2, So 4a plus 0 over 2, and 0 minus 2a over 2. And that reduces to 4a over 2, negative 2a over 2. And 4a over 2 is the same as 2a, just doing 4 divided by 2, and this will be negative a. Negative 2 over 2 reduces to negative 1. Okay, so there's our midpoint. Negative 2a, or rather, sorry, positive 2a, negative a for the y. For our slope for part E, we're using the same points, D and F, and we want to find a slope, which again is y1, or y2 minus y1, over x2 minus x1. So our slope is 0 minus negative 2a, again be careful of that negative, and 4a minus 0. Negative 2a, that's going to be positive 2a over 4a. And again, the a's cancel like the last question, and 2 over 4 reduces to 1/2. So your slope would be 1/2, and your midpoint 2a, negative a. So that kind of gives you an idea of some different types of procedures you're going to be doing. Let's look at an actual proof where we're trying to prove something. So this is our very first coordinate proof. And we're going to go ahead and look at number 4 on your worksheet. Okay, and number 4 is proving that the diagonals of a rectangle actually are congruent. And that's a theorem that we've talked about a lot. We used it for a lot of questions using algebra and some other things. And now we're going to be proving it using our coordinate geometry. So our rectangle is DHCP. P is at 0, 0. D is at the top here. H is 2A, 2B. And C is not labeled either. So first thing we have to do is finish labeling. So again, if this is 2A for our x-axis, then A is somewhere in the middle here. And if this is 2B on our y-axis, then regular B is somewhere in here if we're labeling. So our points for C will be over 2a, up 0. And for D, it will be over 0, up 2b. Okay, so now we have all of our points, and we want to show the diagonals are congruent. So the diagonals, I'm going to go ahead and draw in red on here. Okay, so the first one would come across here, from D to C, and the other one from P to H. Okay. Okay, and when we do these, again, we will have our information written out for us, just like other proofs that we've done. So it'll say given, rectangle, DHCP, prove, DC is congruent to PH. Okay, so we're going to go ahead and go through this. We want to make sure that we do both distance formulas, showing DC and PH, both distances, and then showing that they're congruent. So our distance for the first one, remember first we want to write out our distance formula. Distance formula is x2 minus x1 squared plus y2 minus y1 squared. Okay, and remember we're using DC for our first. So we'll do distance DC. Remember to denote which of your lines you're doing your math for. So we're doing DC right now. And so we're going to take x minus x, which will be 2a minus 0 squared, plus y minus y, which will be 0 minus 2b squared. Okay, so this will be 2a squared plus negative 2b squared. But remember, when we square things, they become positive. So this will be 4a squared. Remember, this 2 goes to both of these. So this is 2 squared times a squared, and that's where I'm getting this from, plus negative 2 squared is still positive 4. Negative 2 times negative 2 is positive 4b squared. Now remember, you cannot simplify this to 2a plus 2b. That's not allowed. If there's addition on the inside, you can't simplify it any further. So that's our distance for DC. Now we're going to do our distance for pH. So this is going to be, again, subtract the x's. So for P and H, we're going to do 2a minus 0 squared plus 2b minus 0 squared. So we'll get 2a squared plus 2b squared. And I know you might not think these parentheses here are important at this point, but because that 2 hasn't been squared yet, they are very important. That does mean that this 2, that squared, belongs to the 2 and the a. So we have 4a plus, or 4a squared, I'm sorry, plus 4b squared for the distance for pH. So at this point, if we look at our distance right here, completely simplified, and our distance here, completely simplified, we can in fact say that those distances are equal. Therefore, DC is congruent to pH. So that's our first coordinate proof that we've completed. Okay, so this is the end of this video. If you have some more questions, we are going to continue in the next video with reteaching 6-7, which will have some more examples and a little bit of different types of questions, as long as some more challenging questions. So tune back in for the next video for some more challenging problems.